Hi everyone, today we're going to be looking at conditional probability. Now recall from last time that when we're talking about probability, we're talking about cards. So we're going to look at if we had to choose either event A, which is picking a red 2, or event B, which is picking out of all the diamond cards. So we're going to be looking first at what is the probability of A, picking a red 2. And then we're going to be looking at what is the probability of picking a red 2 given that we only have diamonds and not all the cards in the deck. Now, the probability of picking a red 2, it is 2 out of 52 because there's 52 cards that we have in total. Now, what if we only have diamonds? So we don't have this card anymore. We don't have the other cards anymore. What if we only have diamonds? So we only have, let's have a look, just these cards here. What are the chances of picking that a red 2? Now we can't pick this anymore because it's not out of what we have. So if we only have diamonds, the probability of picking a red 2 would be just this one out of, now we have 13 cards, 1 out of 13. So let's write the numbers instead. Now, we notice that for this one here, that is our intersect. And we know from last lesson that that's how we represent it. And we know that 13 is everything inside B. So is there a way to symbolize this? The probability of A if only we had diamonds. So the probability of A if only we had diamond can be written as A if only we have diamonds is B. See? Given that we only have B. This line here represents given. So to rewrite this in simple mathematical format, we write A given B. The probability of picking A given we only have B. And so combining these three things that we wrote, we now have the formula probability of A given B is equal to the intersect, which was our 1, the only thing that we could pick out of what we had, over B, which is what we were able to pick out of. So when we look for A given B, is the intersect over B. Notice that the B will always be at the bottom. Let's look at the probability of picking a diamond this time, and a probability of diamond given that we have only red 2. Now the probability of picking a diamond is 13 cards, because there's 13 diamonds in total, out of the 52. And the probability of picking a diamond, given that we only have red 2s, so there's only 2 red 2s. So to pick a diamond, that will be that one there, it's that 1 out of the 2. Again, that 1 is the intersect of A and B, and the 2 is the total of A. So now we can rewrite that formula. So the probability, this is the probability of B given A as that. So notice that B given A, the A is at the bottom of our fraction because that's what we're allowed to choose from. So looking at the previous example and this example, we notice that whatever it's given, it will always be the denominator. So given that statement, sometimes a question may ask you to find the probability of an event, given that something has already happened. That's what we're going to be looking at today. That's why it's called conditional probability, given that a certain condition has happened. This reduces the total amount being considered, so therefore the denominator in the previous examples has changed to just B or just A or just what we're given. Oops, I'm going to move out of the way. It can also eliminate some of the amount that would normally satisfy the question. So the numerator will also change. So for example, from before, the numerator was reduced to only 1 card because there was only 1 out of the lot left over. Let's look at another example. Let's look at the following questions. What is the probability of boys that like intersect guitar, so boys that like guitar, boys union guitar, so people that are boys or they like guitar, and probability of not boys but that like guitar. So for the first one, boys that like guitar, that's the intersect. So we have 3 out of the total, which is 8 plus 3 plus 2 plus 7, which is 20. And B union G would be anybody that likes guitar, and a boy would be these 3 sections, which is 8 plus 3 plus 2 is 13 over the total. The total is 20. So now we're going to look at the probability of not B. So not B means we can't have this, or complement B. Complement B means this and this. Intersect G. Now G is guitar is here. So the intersect is this number here, 2 out of the total, which is 20. Now that we're warmed up, let's have a look at a Venn diagram example that contains given that in the question, or in other words, a conditional probability question. Given that a boy is selected, what is the probability that they also like to play guitar? So we're looking at a scenario where it's given that a boy. So we don't want anything else but the things inside the B circle. So now we can see that the people that like guitar out of this group is just 3. So therefore we write 3 out of 11. This question could have been worded a little bit differently without a Venn diagram. Let's see if we can solve it using the formula that we came up with before. There are 11 boys, 3 of which play guitar. So we're going to have G as guitar and B for boys. Now, 11 boys, 3 of which play guitar. So guitar intersect boys is 3. This is what that sentence is saying. There are also 2 girls that play the guitar. Find the probability of choosing a student that plays the guitar given that it is a boy. Now, there are 11 boys, so boys is 11. And that's all we need, because the question is probability of choosing a student that plays guitar. So probability of a student that play guitar given that this is a boy, given that it is a boy. So remember that the formula, it is the intersect of the 2 things that we're talking about over the second thing, given that's a boy, so probability of B. So now we have the intersect is 3 and the boys is 11. So the answer is 3 over 11, just as we expected, like we did in the Venn diagram before. Let's have a look at another example. 120 students stated that favorite subjects are the following: 48 like maths, 50 say history, and 23 like both maths and history. Here's a Venn diagram that I prepared earlier. Let's have a look at the following questions. People that like history, people that like maths given history. For people that like history, we can see that there are a total of 27 plus 23, which is 50, out of the total of, in a question we said 120. We can further simplify this. We can simplify this by cancelling out the 0 and getting 5 over 12. But let's not fuss about that. So now let's look at the second question. People that like maths given that we're only allowed to choose from history. So people that like history are those ones that are highlighted there, 27 and 23. So we're not picking any other numbers there. So that is going to be our total now, which is 50. And people that like maths in that group are our 23 over there. So now we have 23 over 50. So previously we saw that B given A is equal to the intersect over A. Now if we move the A over that side, the opposite of dividing is multiplying. Now we have probability of A times B given A. is equal to the intersect. And now if we switch them left and right so that they're still equal, we have the intersect over here and that bunch over there. So probably the intersect can be worked out by finding the probability of A times B given A. And remember that always has to match up. Let's look at this question using the formula that we just worked out. The probability of a student that likes playing guitar is a quarter. The probability that a student likes guitar, given that he's a boy, is 3/11. What is the probability that a student selected at random is a boy and likes guitar? The probability of somebody who's a boy and likes guitar. So the intersect. Now that is going to be, let's have a look at the information. A student likes playing guitar, so G is equal to 1/4, or more accurately, probability of G. And that 3/11 is the probability a student likes guitar given that is a boy. So G given B is 3/11. Now we knew the intersect from before, that it is equal to that formula over there. So it's equal to probability of guitar times probability of boys given guitar. Remember that always has to match. So now we have a quarter times 3/11. So we have 3/4 times 11 is 44. So that's another way to use that formula. Let's have a look at a tree diagram question. 2 balls are chosen from a bag of 10. See, there's 10 balls there. This is the bag. Given that a blue ball is picked first, what is the probability of picking a red ball? So in our first event, we are going this direction because we're picking a blue. So this doesn't happen. So none of this we have to worry about. So looking at the question, what is the probability of picking a red ball? So the chances of picking a red ball is over here, 8/9. Nice and simple. So make sure that when you draw the diagram, the tree diagram, you're very accurate, and answering the question will be a breeze. Let's look at a question that has dice in them. Determine the probability that the sum is less than 10, given that a double is rolled. So this time, the given part is a double is rolled. And what we want is the sum is less than 10. So you're adding it up and it has to add up to less than 10. Adds to less than 10. That's what we want. First, draw a two-way table. So let's draw a two-way table. That's really, really handy because from the two-way table, we can see our first row in red and our second row in blue, and we can quickly identify what we want, which is we can only look at doubles. So let me do that. Let's highlight all the doubles. So that's all the doubles that we want. And what we want is that they add up to less than 10. Which of these add up to less than 10? Let me put that back really quickly. So that adds up to 2, that adds up to 4, that adds up to 6, 8, or 10. 10 is not less than 10. So we have 4 that add up to less than 10 out of what we're allowed to pick, which is 6. So we can simplify this to be 2/3. So drawing a two-way table is very handy for this kind of questions. Let's look at one more. Determine the probability that a double is rolled given the sum is 6 or less. So this time we want a double given that we have a total of 6 or less. So it can be equal to 6 this time. So here are the things that add up to 6 or less. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 things to choose from. And out of these things, the doubles are, oh, maybe I'll pick a different color. Let's go with purple. Okay, out of these, the doubles are 2, 2, 3, 3, and 1, 1. So we have 3 things that we can choose from. And we can simplify this by dividing by 3. And that is our answer. Now be very careful that when we say 6 or less, it's very different to less than 6, because less than 6 means we can't pick the ones that are equal to 6. So the same question, but this time the last bit is different. What is the probability that a double is rolled given that the sum is less than 6? So a double given that is less than 6, so less than 6. Sorry. So there's no little equal sign this time. So now the less than 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 2, 2 and 1, 1 as a double, so there's 2. 1 out of 5. All right, that's it. Bye.